Hello, students. This will be lecture 4 and then the last part of lecture chapter 4, 4D. And then that is an example of atoms, the last example of section 15.3, and the mass of a wire. And the mass density is given. That is x times y. And then the wire is given, and the wire is given as an intersection of two surfaces. The first surface 2 minus x squared minus y squared, and the other z is x squared. Now I do it a little bit else than Adams is doing. You see z satisfies some equation, another equation. We may also put them together to get them equal. So x squared becomes 2 minus x squared minus 2y squared. And if you rearrange it a little bit, you get out of it that x squared plus y squared is 1. So you have in the xy plane the unit circle, your z is free, so you have a cylinder parallel to the y-axis. And your z is free to choose. And then you have also that the parabolic cylinder, and I think that is easier to make some sketch of the curve of the wire of which we have to calculate its mass. Given are the points 1, 0, 1 and the point 0, 1, 0. Now let's some sketch. So we have the x-axis, y-axis, z-axis. We have the point 1, 0, 1. So this is 1, 0, 1, and you have the point 0 and then 1 in the y direction and 0 in the z direction. So those 2 points you have, they were given. If we have the intersection of a cylinder parallel to the z-axis with that parabolic cylinder, so we have in the xy plane we have a circle with radius 1, and you have a cylinder, so you can go up with that circle. And then you have here your cylinder, and then you have that parabolic cylinder that is in the zx plane. You don't see any y, and your y is free. So, and then you can shift that parabol along the y-axis, and you have your parabolic cylinder. And then that cylinder, the green cylinder and the parabolic cylinder are cutting each other, and that gives you some curve. That is the wire where you have to calculate the mass of. Now, then, so asked to us is to integrate that mass density over that curve. This is calculate it. This gives you the mass. And what can we do? We can take for the x, that is the point on the wire, we can take xt sine of t, and then the z is equal to x squared, so that becomes the cosine squared. So this is your parameterization. and your t you can take, for instance, between the 0 and pi divided by 2, and then you have exactly that curve which you have there. So here you have parameterization. Then you can calculate the velocity vector minus the sine of t cosine of t, and then you have minus 2 times the sine of t times the cosine of t, and you have to calculate its length to get the ds term. So the ds term becomes the length of the velocity vector times dt, and if you calculate the length velocity term, you get sine squared plus cosine squared, that is 1, and then the other term squared gives you 4 times sine squared times cosine squared dt. This is the length of the velocity vector dt. And now we can write down the integral. So the mass becomes equal to the following: the integral from 0 to 2 pi, of 2 pi, pi divided by 2, I mean, and then we have x, that's the mass density was x times y, so that becomes x times the cosine of t, and then we have the ds term, and that was that expression we have just written down, and you have to take the square root of times dt. So here you have your mass density, and this term here is your ds term, and that we have now filled in our parameterization, and now we can go to calculate. It is a long calculation, but okay, we can do it. I thought to myself, the sine of 2t is equal to 2 times the sine of t times the cosine of t, so that integral we can also write as the integral from 0 to pi divided by 2, and then 1 over 2 times the sine of 2t times, and then we have 1 plus the sine squared of 2t, and there the square root of dt. So I have just written down on some other way. Then I know the cosine squared, cosine of 2t is equal to cosine squared minus the sine squared, and so I see that the sine squared of t is equal to 1 minus the cosine of 2t divided by 2, and uh, and yeah, I want to have some cosine here, because I see outside the square root you have a sine of t, and the derivative of the cosine is the sine, so maybe we can then calculate some primitive function. So therefore I'm doing this, but be careful, you have here the sine of t, and I need the sine of 2t. Be careful. And so what does the integral gives us? That mass becomes equal to that. No, the boundary are not changing. The first term is not changing, but then we have 1, and then we have plus 1 over 2 times 1 minus the cosine, and don't make and be careful, the cosine of 4t dt. So be careful. You have here you get here staying 2t, and then you have here you get 4t. So we have this expression here. This becomes 1 over 2 integral, same integral, and then we have the sine of 2t times, and then we have 3 over 2 minus 1 over 2 times the cosine of 4t, taking the square root of it, dt. Now we have already done something, but then I'm not so nice, because I have here the 2t and I have here 4t, so I'm not completely well with it. Now what to do then? The cosine of 4t, that is equal to cosine squared 2t minus the sine squared 2t, and I am interested in maybe something with the cosine, so I can rewrite this one here as 2 times the cosine squared of 2t minus 1. And if I now rewrite, what do we have? We get a 1 over 2 integral from 0 to pi divided by 2, and then we have the sine of 2t, and then fill in that cosine 4t, that expression of, and fill in, and we get out of it 2 minus the cosine squared of 2t. Now I thought that I should have almost the solution, but that is not the case. I cannot still not integrate, because I have then problems with the derivative of the cosine squared, and that gives you something, the sine, but also with a cosine, and that I don't have. Now what then? Let's go to let's do the following. Maybe we can try to change it a little bit. Let's take a new variable, the cosine, and let u be cosine of 2t. Then we have that 1 over 2 du becomes equal to of minus 1, that becomes the sine of 2t dt. Just take the derivative of du dt and then change it a little bit, and then we have this expression here. And so what does that gives us? That gives us that the mass we are still calculating becomes minus 1 over 2, and then the integral from, if t is 0, we have the cosine becomes 1, and if t is pi over 2, we have the cosine of yes, and then we have the cosine of I get from this one to 0, and then we have also 2 minus u squared du du. And I hope that I have done everything well. I'm not completely sure, but okay. And that we can change, and then we have the du divided by 2, yes. And this 1 over 2 is from the integral, which we have already, and this is from the change of the coordinates. And so what do we have then? We have then the integral. If we change from 0 to 1, if we change that, we have from 0 to 1, we have also a minus sign, and so we have 1 over 4 times, and then 2 minus u squared du. What then? Now we can take another variable and let u then be equal to the square root of 2 times the sine of t. Then the du becomes the square root of 2 times the cosine of t dt. Okay, and if t is 0, your u is 0, and if t is sorry, I want u to be then t becomes equal to the sine of no, I want to have that one. U is equal. Let me do some. Yeah, u is this one here. That is no problem. That's okay. But I have something lost. Or not? No. I get this one here, and I don't know what to do else. I have just to fill in it then. So what do I have then? The integral if t the u is equal to that. If u is 0, your t is 0, and if u is 0, t is 0, and if u is 1, your t is equal to pi divided by 4. So we have the integral from 0 to pi divided by 4. All right, we have an 1 over 4, and then we get, if we fill in that u, you get square root of 2 times 1 minus sine squared. So 1 minus sine squared, the square root of it, and we have also a square root of 2 times the cosine of t. And so we have also a square root of 2 times the cosine of t dt. This is your du term, and the square root of 2 comes out of the square root. Yes. So what do we have now? Now we have the integral from 0 to pi divided by 4, and then we have square root of 2 times square root of 2 is 2, divided is 1 over 2, and then the square root of that gives you the cosine of t, and so you get cosine squared dt. Now here you can again use that formula for the cosine, and then you go with that you have that formula with 2t, the cosine of 2t. And what do we have then? We have here 1 over 4 times 1 plus the cosine of 2t dt. Now, and we want to do so. Now, what do we have? We get 1 over 4 times t. That is this one here. And we have also plus 1 over 8 times the sine of 2t. And that between the boundaries 0 and pi divided by 4. And yes, and then I have lost something somewhere. I have not done well, but I don't know where I have done that. I'm doing well. Mm, I have somewhere not completely well, but I don't know. But because if I'm now filling in, I get this one here plus 1 over 2 times 1, and I have something lost. Uh, I have lost some factors somewhere, but I don't know where. No, I don't know. So somewhere I lost some factor. Sorry for that, but I hope that you can recalculate and that you see the steps which I have done here. And I have used very much of that cosine and sine formulas to calculate it, but you can do it. I think you